I assume everyone's written this.
No.
Do any of you know who Julius Caesar was?
Yes. Yes.
Yeah. Emperor, Rome, old guy, really powerful. At one time, had a huge army, ruled a big portion of the world. Have you ever thought about how he talked with his generals on the battlefield? You know, if you were to just write a letter in plain Greek, I suppose, then any person who intercepted that letter could read it and would know exactly what they were planning on doing, right? So what Caesar did was developed a way to code his messages. Meaning he would write them in a way that if someone were to just pick it up and read it, it would not make sense. And this is what he would do. Tell me if you can see the pattern here. He would take an A and make it an E. And any B that he saw in his letter, he would change it to an F. And any C, he would change it to a G. And he would do this for his entire letter. This is called the Caesar Code. Do you see the pattern?
No. Yes. No. Talk better. Yeah.
Okay, well, how does this have to do with our homework?
You'll see.
You made a table.
Jay, what's the pattern?
Every 4 letters.
Yes. He replaced the letter with the one which comes four later. 1, 2, 3, 4. Every A became an E. Every B became a F. He essentially took his letter, added 4 to it, and took that new one. How does that have to do with what we're talking about? Well, that's a mathematical pattern, isn't it? We see that if we could replace these with numbers, for instance, the numbers 1 to 26, what he essentially did was took the first letter and made it the 5th. Took the second letter and made it the 6th. We changed his code into a numbering system, and guess what we can do with this now? We could write a function for it, right?
We could.
What is the function? Kelsey, go for it.
Okay. Y, we can do Y, right?
Sure, okay.
Y equals, never mind, I don't know.
Delia.
The y equals your number plus 4.
Yes! Now, writing that as a function instead of y, what would you write, Daniel? Depends on the variable. We're using x. F of x equals x plus 4. Perfect. Now, we run into some problems here where we get to 26 and we add 4, we get 30. What does that mean? Well, that means we start back over at the first letter, right? Go back to 1, 2, 3, 4. Okay? But this is a good example of a real-world application of a function. Okay? Delia, question?
Go back a slide. The hello equals, isn't that in the Caesar code? Word.
H goes to L. E goes to
Shouldn't
I.
the L's be on a different
Really?
one
L-I,
for the H-E-L-L-O?
Oh my goodness.
the L-I-P.
It should be
I
lips.
that.
I'm gonna say Hadley's like that.
How?
Hello.
Oh, wow.
Just so that I never make that mistake again.
Where is lips? No,
How
how long
can
your
you
lips?
put it?
And Caesar's code.
Lips.
See?
No.
Lips.
Hello
No,
equals
lips.
lips.
So that's
They're
what
like
hello
this.
means in their language?
Lips.
No, no, no.
No. Hello
For
is
instance,
what
if
it
you were to say hello,
is.
but instead you were to
Okay.
code it differently using this function,
You say lips.
you would write lips instead of writing hello.
Lips, Kelsey.
Lips was here too, Miss C.
Okay, lips, class, lips.
Ow.
Also,
love.
lips. Okay? Now, this was the function that we had just found. F of x equals x plus 4. So that was sort of a roundabout way to getting at about analyzing a table to write a function. Here I'm really just going to give you a table of numbers, and we're going to try and find the function. But remember that we are writing linear functions, which means that we are going to need to somehow find a slope and a y-intercept for our equation. Every line has a slope and every line has a y-intercept. So here's our table of values. Lisa, how do you think we're going to find the slope? I kind of asked you this question yesterday. How do you find slope? Just in general.
Count
You count what?
numbers.
Yeah, and which numbers are you counting?
First one. No.
Pick someone else to help you out. Again, the question is, what is slope?
Kayla.
What? You think I know this?
You do.
Yeah, how do you calculate slope?
You like those numbers that are in the little equation thing.
There's a 3-word definition you could give me.
Wait.
Never mind. What? Wait, no.
The
3 words.
3 words. It's very, very short. Lisa, back to you.
Is it run?
So that's one of the 3.
I know.
Back to Michaela.
the rise.
Overrun.
Rise over the.
Yeah, rise over run, or rise divided by run. So from this table, we are going to try and find the rise, and then we're going to try and find the run and divide them. Also, from this table, we're going to try and find the y-intercept. Okay? Now, the y-intercept, how did we find that when we just had a normal graph? Daniel? Yeah, you looked along the y-axis and you found where the line crossed it. And then from y equals 0, you counted up. 1, 2, 3, 4, until you found the number it crossed the y-axis at. That's one way of doing that. And that number that it crosses at is the y-intercept. Okay? Now, you're counting along the y-axis, right? So what does x equal at the y-axis? Have you ever thought of that?
No.
Who said that? The y-axis is at 0. X equal to 0. So to find the y-intercept from a table, you look at the row where x is equal to 0. So in this table, we've got a column here, and each column, or this column, represents the values that x will take. So you'll input 0 for x, and you'll input 1 for x, and 2 for x, and 3 for x. And this column here represents the values that the function takes when you plug in x. So when you plug in 0 to our function, which we still don't know, it will give you 0. And when you plug in 1 to our function for x, you get 3. And when you plug in 2, you get 6. When you plug in 3, you get 9. Okay? So this is simply the coordinate pairs x, y for our graph. X is going to represent our run, the left and right. F of x is our heights of the function. Okay? And all of those things are good to know because for the slope we need to know the rise, the change in height, divided by the run, the change in left and right, the change in x. And to find the y-intercept, we need to find our function value when x is 0. So which one's easier right now? Which one do you think?
0.
The y-intercept. Because it's right here. What is f of 0? Here's x equal to 0, which means f of 0 is 0. Our y-intercept is 0. Easy. So our function is going to be f of x equals mx for some slope m plus 0. Now what is that slope? Well, your book does something similar to what I'm about to do. I think it makes some good sense. So I basically, I'm using the same method your book does. In this table, the x values change by a certain amount every time. X goes from 0 to 1, and from 1 to 2, and from 2 to 3. It changes by plus 1 every next one, right? It goes up by 1 every row. Okay? So your book notices that, and it writes that down for you, just like I did here. So the run in this problem is 1. Run is the change in x. So if you have a change in x of plus 1, notice x changed by 1 from here to here. That's our run. Now we need to use that number as well as the rise for the corresponding numbers. If we go from this row to this one, the run is plus 1, but what is the rise from this number, or from this row to this row? Misty's saying it out loud. I wish you would raise her hand. Ilsa already knows the answer because she said it. It's 3. Okay? From this row to this row, we had a rise, or a change in f, of plus 3. So to find the slope, you take a rise divided by the corresponding run.
That is
3 divided by 1 is the slope. So our function is f of x equals 3x plus 0. Yes?
Does the y-intercept always equal f of 0?
Yes. Now you don't have to write the y-intercept if it's 0. I did here so that you can see that it is 0, but you don't really ever have to write it if it's 0. So you very well could have written f of x equals 3x, and that's fine. Okay? Because essentially plus 0 is plus nothing.
So,
A couple questions here. Yes?
what was the answer to that? F of x equals
3x plus 0. Is it hard to see it from there?
no.
Okay. All right, the next portion of our lesson is trying to find that function rule from a graph. We just found one from a table of values, but now we're going to find one from a graph. And Misty, you said earlier, or you asked earlier, isn't a graph the same as a table, right? You asked that? And I said, well sure, it is. So we're going to do pretty much the exact same thing, but for a graph instead of for a table. Okay? Ready to go on? All right. We still have the problem of needing to know the slope and the y-intercept. Okay, those two things are necessary to write a linear equation. You need to know the slope of the line, and you need to know the y-intercept. So I'm going to give you a line here, and a couple points on it. And I'm wondering if you could already find the slope and the y-intercept. This is something you've already done. 2 lessons ago, we did this.